firstly for the lengths of the unknown sides, okay? Now, if I were to calculate the perimeter of this figure, I'm going to have the length of the side. And I can see if that's a right angle, then this falls on a straight line, so this has to be a right angle. So I'm going to take this right angle triangle, I'm going to apply the theorem of Pythagoras to it, and I'm going to get the length of that side that I do not know, but I need it in order to calculate the distance right around this figure. So let's do that firstly, okay? So I'm going to say, remember, opposite my right angle is my hypotenuse, okay? Or if you just simply want to say this is A, this one is B, and that's C, it makes it easier to work with. So we're going to say A squared, which is my hypotenuse, is equal to the sides. You know the sides where the right angle forms? It's a sum of those sides, those two sides on there. So it's equal to B squared plus C squared, okay? And then if I go and substitute my values there, I'm going to get for B 3 squared. Here there's no units of measurements, okay? And for C, I've got 4 squared. So in my calculator, I'm going to say open brackets, 3 close brackets squared, plus open brackets 4 close brackets squared, and I'm going to end up with 25, okay? So I'm going to write that down here. I've got A squared is equal to 25, and then A is equal to the square root of 25. In my calculator, if you do not know that answer, then it's square root of 25, which is equal to 5. Okay? So I'm going to say that the length of A is 5. Okay? So let's put that down here. This is 5. Then I'm going to go, that side is 8. Now for the circular part here, it's a distance around that semicircle. Okay? And when we talk about circles, when we talk about perimeter in circles, we refer to it as circumference. And we know that the circumference is 2 pi times the radius, okay? So I need to get the value of the radius. Now if I look at this rectangle, this length here is 4. So directly opposite it, this will also be 4, okay? And then the radius of this would be halfway through this. So if that length is 2, you can't see that, then the other radius part here will be 2. So it's the midpoint of that line segment, and if the entire length is 4, then the radius will be equal to 2. Okay? So I can go and calculate the circumference here by saying the circumference is equal to 2 pi multiplied by the radius, which is half that length there, and that is 2, and this is 4 pi. Okay, so that's the circumference of an entire circle, but I only have a semicircle. So a semicircle is half the circumference of a full circle. So the circumference of this part here, I'll take it and I'll multiply it by half. So 4 pi multiplied by half will give me 2 pi. And if you do not like working with pi, you can go to your calculators and you can see that it would give you the value for pi, but you can also leave it just like it is. I'm just trying to see, James, help me, okay. If you look at the writing on the calculator here, we have the yellow writing that will go with that yellow key there, okay. So I'm going to say it's 2 multiplied shift pi, and that's equal to 6.28, okay? So this is equal to 6,28. So the distance around here will be 6.28, all right? Because it's a semicircle, half of that circumference of the circle. Now if I look at the bottom here, that entire length there will be exactly equal to that, which would be 8. But I've taken out a portion of it here. So that portion that I've taken out will be 2. So the balance of it would be 8 minus 2, which is 6. Then I go 6 there, I go 2, 2. This here is a square, so that length will be 2. And then I've got 3. So it will be very easy now to just add up those lengths and get the total length of that diagram. So let's do that very quickly here. I'm going to put a line in here. We're going to say the perimeter is equal to 5, which we've calculated using the theorem of Pythagoras, plus 8 plus 6.28 plus 6, which is at the bottom here, plus 2, 4, 6, or we can say 2 plus 2 plus 2, and then plus 3. Okay? And then I'm going to use my calculator to calculate that. I've got 5 plus 8 plus 6.28 plus 6 plus 2 plus 2 plus 2 plus 3 is equal to, in decimals, 34.28. Okay, so that's the perimeter around the shape. And I hope we all got the same answer. If not, please check your working. Now to calculate the area of the shape, we've got to calculate the area of the triangle. Okay, that would be the base times the height. Okay, we've got to calculate the area of the rectangle, which is the red figure. That would be 8 multiplied by 4. Okay, then we've got to calculate the area of the semicircle, which would be half pi times radius squared. And then we've got to calculate the area of the square. So I'm going to write that all down. So the area will equal to the area of the circle plus the area of the rectangle plus the area of the semicircle. Just write it like that, okay? Plus the area of the square. Okay? Right, so that makes it easier, just graphically drawing it instead of writing the whole word. Let's look at the area of this triangle. The area of the triangle is half base times height. So I'm going to write the formula down. It is half base multiplied by height plus the area of the rectangle is base multiplied by height. The area of the semicircle is pi times radius squared, but because it's not a full circle, it's half the circle, I'll put half in the front. Okay? And the area of the square is base times height, or we can just say side squared. Okay? If you do not like this here, let's just write it correctly. It is side squared because a square has all the sides that are equal to one another. So it's side times side. Okay? Now let's go and substitute. For the triangle, we have the base, which is 3, meeting that height at right angles is 4. So it's 3 multiplied by 4 plus, if I look at the rectangle, it's a red one. It's a base, which is 8. Meeting that at right angles is 4. Okay? So it's 8 multiplied by 4 plus half pi times radius squared. And I said my radius in that diagram is half the length of that side, which is 2. So it's 2 squared plus the square, which is the green one here at the bottom, is the side multiplied by the side, which is 2 times 2, or base multiplied by height is 2 times 2. Okay, so that's 2 squared. Now we're going to work out each one of these separately. We're going to put down our answer, and then we're going to add them up. Okay, for the first one, it's half 0.5 multiplied by 3 multiplied by 4, and that would give me 6. Okay, so I'm going to write down 6 plus the next one is 8 times 4, and that is 32. Or if you want to use your calculator to confirm, say 8 multiplied by 4, and that will give me 32. Okay, the next one is half pi multiplied by 2 squared. Okay, so I'm going to put that in my calculator. I'm going to say 0.5 multiplied, and to get pi, I must press shift and then that button where the pi is in yellow, the shift is in yellow, so that I know I can get the pi by pressing that shift button, multiplied by open brackets 2 close brackets x squared, okay? And that's going to give me 2 pi, but I want it in decimals, so I'm going to convert it to decimals, which is 6,28, okay? So that's 6,28. So this is quite a unique semicircle. It has a circumference, which is 6,28, and it has a area, which is 6,28, okay? So it's quite unusual. And then we have the last one, which is 2 squared, and we all know that is 4. So let's add up all of these areas to get the total area. We have 6 plus 32, 6 plus 32 plus 6.28 plus 4, which is equal to, in decimals, 48.28. Okay, so it's 48.28. And there's no unit of measurement, so we can leave that out for this question.